In this video, we are going to take the log of each side of the equal sign to help us solve for that unknown variable. So we do this when I don't see any logs here and it's an unknown exponent. So I want to figure out what is b equal to. I don't know if you want to figure it out, I want to figure it out. So log of each side is when we take whatever the base of our exponent is. So here the base of this unknown exponent is 3. So what I'm going to do is use log of that same base. So I'll use log base 3 and then write this again. So 3 to the b equals, and if I did log base 3 on this side, I have to do log base 3 on the other side. Okay, so I have log base 3 for both sides. So my goal is to get this log base 3 and of 3. So for these two numbers to be the same. Because if you think about 3 as your base, 3 to what exponent equals 3? Well, 3 to the first power equals 3. So this is going to cancel out and become 1. And another way we can look at it is checking on our calculator. So log base 3 of 3. So I'm going to use my change of base rule. So that would be, this is another way, so log of 3 divided by log of 3 would be the change of base rule. Same thing divided by the same thing, that's equal to 1. So just to show how that would cancel out. But log base 3 of 3 cancels, and I'm going to bring that exponent down to be a regular old variable, equals log base 3 of 17. Okay, now to calculate log base 3 of 17, I am going to put that in the calculator. So log base 3 of 17, we're going to use the change of base formula. So that's when we do log of 17, so that's what I'm going to type in, log 17, and the parentheses, divided by log of 3, so log 3. And that is going to equal, I'm going to go out 4 decimal places for this one, so 2.5789. So b is equal to 2.5789. Okay, let me adjust this light here. Okay, so that one is just like number 12, the one that you would start off with in the practice. Numbers 13 and 15 will be more like this example here. So for this example, I have 11 to the n minus 8 minus 5 equals 54. So we need to get this number with the unknown exponent alone first. So right now I have a minus 5 with it. I am going to add 5 to both sides. So this is 11 to the n minus 8 equals 59. And now to find that unknown exponent, so this has my unknown exponent, I'm going to take the base, log base of the same base of my number here. So this will be log base 11, and then 11 to the n minus 8 equals log base 11, so we have to do it to both sides, of 59. Alright, so this light is a little too bright, isn't it? So from here, now I have my log base 11 of 11, so those two numbers are the same. So I'm going to cancel that out and bring my exponent down. So this will be n minus 8 equals log base 11, 59. Okay, so it's pretty obvious the next step here would be to add 8. But be careful because we're not adding 8 to any of these numbers here. This is a number of its own. So we want to calculate what that number is equal to. Okay, so when I go to calculate that, change of base rule, again, I want us to get comfortable with that. So we're going to have log of 59 divided by log of 11 and hit enter. Okay, so this number that I get in my calculator, I'm going to leave it here. I'm not going to write it down on here and then just use that rounded number for the final answer. I'm going to keep it on the calculator, and then I know I need to add 8 to both sides, so I'm going to add 8 to what I have here. So this plus 8 will give me 9.7004. So I'm just going to write this as n equals, so I'll write it out to the side here, n equals 9.7004. And that's the answer to that one. Okay, so now in this next problem, we have 6e. So now we're working with that new number e. So treating it the same, this is e raised to this exponent, because remember e is a number. So this number e is being raised to this exponent, so I need to get that alone first. This problem is similar to numbers 14 and 16. Okay, so to get this alone first, I'm going to add 3 to both sides. So I'm going to be left with negative 6e to the 8n plus 8 equals negative 20. So that's just that, negative 23 plus 3. And I still want e to this exponent alone, so I'm going to divide out negative 6 on both sides. Okay, so now I'm left with e to the 8n plus 8 equals positive 10 over 3. Okay, so now I'm going to take the log of both sides to solve for this. My base is e, so remember log base e is ln. That is our natural log. So I'm just going to do ln, our natural log, to both sides. So I'll have ln e to the 8n plus 8 equals ln of, I'm just going to put that in parentheses, 10 over 3. Okay, so ln e is what cancels, and I bring my exponent down. So I have 8n plus 8 equals ln of 10 divided by 3. Okay, so we just want to finish up solving. So I want to see, what is ln of 10 divided by 3 equal to? So you have an ln button on your calculator. I have ln of 10 divided by 3. Okay, so again, I'm going to keep this number in my calculator, but for now I'm going to write it rounded on the paper just to have it down. So I have 8n plus 8 equals 1.204. So I'm rounding here, but I'm keeping the same number in my calculator. I'm just putting a number here so I know what operations to do next to look. So first I'm going to subtract 8 from both sides. So I'm going to subtract 8 from here. Again, rounding that answer on the paper, so negative 6.796. So negative 6.796. And now I'm going to divide by 8 on both sides. And divide by 8 in the calculator. So that this answer is going to be much more accurate rather than rounding as we go. So this is going to be n equals negative 0.8495. Okay, and I'm just going to box that off, and that is our answer.